Welcome, fellow chemists. Today's video will cover the activity series and its use in predicting the outcome of single replacement reactions. This video is a step up from the first one, as it not only assumes you know how to use the activity series, but we will also develop the formulas for the products and balance the equation. Before that though, let's quickly review single replacement reactions, which are quite simple. A single element and a compound react to produce a new single element and a new compound. Notice the single element represented by letter A is sitting at the front of the new compound as it replaced the letter B, which used to be there. This happens when the metals or hydrogen are involved. In reactions involving halogens, the single element replaces the element at the end of the compound instead. I will dedicate a future video to writing formulas, but for now I'm assuming you have some knowledge of ionic formulas because that is what we need. In them, the positive ion, usually a metal, comes first, followed by the negative ion. Though the individual ions have charge, the final formula has no charge as positive and negative cancel out. Speaking of charge, I will not be following convention right now. According to the IUPAC, I should express charge number as follows, but I am going to write them more algebraically for a specific reason. So why is the formula for sodium chloride NaCl? Simple. Sodium is first as it is the metal, with the nonmetal chloride following. Only one of each ion is needed because the sum of charges is 0. I feel if we are adding the charges together, then we may as well write them as we would adding anything else, even if it's not conventional. Also, it's not always as simple as NaCl. If we add calcium, a metal with a +2 charge, and nitrate, a polyatomic ion with a -1 charge, we put them together like before, but the charge does not cancel. Since we have an excess of positive charge, we need another nitrate ion. This will now bring the overall charge to 0. We don't extend the formula to look like this. Instead, anytime a polyatomic ion is required more than once, place it in parentheses with a subscript on the outside bottom right indicating how many are needed. Now on to using the activity series, and spoiler alert, in all these examples there will be a reaction. Magnesium is more reactive than aluminum, so they switch places. Aluminum as a product is pretty simple. It's a metal, and so the symbol alone is sufficient. What do we get when magnesium and chloride come together? We saw earlier, chloride is a -1, but magnesium is a +2. Place magnesium before chloride and the charge is currently +1. If we add another chloride, the charge drops to 0. Of course, the proper formula includes a subscript 2 by the chloride. Now that we have the products, we can balance the equation. We start with counting all of the atoms on both sides. Since chlorine is the only one unbalanced, we try to fix that element first. During the process, we throw magnesium and aluminum out of balance, but it is a relatively simple fix by the end. Now for a reaction involving the halogens. Fluorine is the most reactive halogen, so it will kick bromine out here. Bromine becomes a product, but all isolated halogens exist as molecules which are diatomic, so the correct formula is not Br but Br2. When a single potassium, a +1 ion, meets up with a single fluoride, a -1 ion, they happily balance and we need no subscripts in the formula. Unlike the formula though, the equation is not happily balanced. After the initial count, fluorine and bromine are the ones not balanced. Picking bromine first for no particular reason requires a 2 in front of Kbr, which throws off potassium momentarily. Placing a 2 in front of Kf not only balances fluorine, but returns potassium to its happily balanced state. Now on to the final example. Though you don't think of hydrogen as a metal, it is included on the typical metal activity series. Aluminum, of course, is more reactive, so it will kick out hydrogen from sulfuric acid. That means hydrogen is the newly single element, and just like the halogens, it exists as a diatomic molecule. As for the other product, aluminum is a +3 ion and sulfate is a -2. Having one of each doesn't work as the overall charge is +1. Add another sulfate and the charge is -1. Another aluminum, it becomes +2, which a third and final sulfate can bring down to 0. With the correct formula, this means we can move on to balancing the equation. To keep things simple, I'm going to keep the sulfate together as I balance. After the initial count, a 2 in front of the left aluminum is needed, as is a 3 in front of sulfuric acid. Once a 3 is placed in front of the hydrogen product, the equation is finally balanced. Although we added formula writing and balancing to the concept, this is as hard as the activity series gets for most first-year students. Remember that the more reactive element always wins. The correctly written products indicate metals as monatomic, halogens or hydrogen as diatomic, and ionic compounds with no excess charge. After writing the correct products, the equation must be balanced. You'll get the activity series for each practice problem, and I provided a useful link in the description to a list of ions. Good luck with them, and as always, thank you very much for watching.